This is the first of two recordings for BIOS500 Lab 6. In this first recording, we're going to talk about how you can use SAS to calculate probabilities, which you normally would use either the binomial formula for or the Z or the T tables, depending on which random variable you're interested in. So SAS actually allows you to calculate probabilities for the binomial, normal, and T distributions using functions that are built into SAS. For example, if you wanted to calculate the probability that x was less than or equal to some integer k, and x is a binomial random variable with n trials and probability of success p, you would use the prob BNML function in SAS, and this is one that I've demoed in lectures before. You supply three arguments to the function, the p, the n, and the k for the probability in question, and you set the result of that function equal to a new variable that you create. You can do something similar if you want to calculate probability that z is less than some particular value, less than or equal to some particular value, and z, of course, is a standard normal random variable. You don't use the prob BNML function there, of course. You use a different function, the prob norm function. That is specifically designed to calculate probabilities like z less than, or probabilities of events like z less than or equal to some specified value. Simply call prob norm and supply the specified value of z that you're interested in. We'll have examples of each of these coming up. Likewise, if you're interested in the probability of a random variable from a t distribution being less than or equal to some specified value little t, well, then you call the appropriate function, which happens to be prob t, and you have to supply two pieces of information, two arguments for the prob t function. Those are the value of t and the degrees of freedom for the distribution. Alright, some examples should help to make this a little bit clearer. Let's suppose we want to work out these three probabilities. Probability x less than or equal to 3, where x is a binomial random variable with 10 trials, n equals 10, and probability of success p equal to 0.1. And let's suppose that we also want to work out probability z is less than or equal to 2, where z is a standard normal random variable. Finally, let's suppose we want to work out probability t is less than or equal to 2, where t follows a t distribution with 100 degrees of freedom. These are just examples. I made them up. They have no particular significance in and of themselves. Well, here's a SAS program which will calculate each of those three probabilities. Now, I've already copied and pasted the SAS program into my SAS session, so let's go there. And I'm going to add a few blank lines here to make the program a little bit easier to read. Okay, so now these probability calculations have to be done within a data step. You can't just do them outside of a data step. In SAS, the results of the function calls will be stored in variables, and variables are stored in data sets. So basically you have to create a data set within which there will be variables, and those variables will have as their values the probabilities that we're trying to find. So I'm creating a data set called prob underscore functions. Notice that there's no lib name at all, no lib ref in front of prob underscore functions. That means it's going to be a temporary data set. It'll be in the work library. What are the variables in the data set? Well, I'm not inputting any variables. I'm not importing any variables. I don't have any data lines here. I'm simply going to create three variables. Look at this. One of the variables is PR underscore X underscore LE underscore 3. A very awkward name to type in, but that stands for probability X less than or equal to 3. It's a perfectly legitimate SAS name. And then another variable will be PRZ less than or equal to 2, with underscores separating the various pieces of the name, and PRT less than or equal to 2. So I usually make up boring variable names, but these variable names are reflective of the probabilities that will be the values of each of the three variables. Let's go back to the first probability. Now that was going to be the result of a calculation from a binomial distribution. We want to calculate probability x less than or equal to 3, where x follows a binomial distribution with 10 trials and probability of success 0.1. The comment here reminds us what we're calculating and for which random variable. Well, that is achieved by calling the prob_BNML function and giving it the three arguments, the p, the n, and the k. P is 0.1, n is 10 for 10 trials, and k is 3. That's the value we want x to be less than or equal to. It's as simple as that. You create an assignment statement, basically. That is, you create a variable and you set the result of that variable equal to the call, the function call for the appropriate probability distribution. So similarly, for probability z less than or equal to 2, we're going to say this new variable equals prob norm, and then 2 is the only argument that's needed for the normal probability calculation. For the probability t is less than or equal to 2, where t follows a t distribution with 100 degrees of freedom, well, that newly created variable is set equal to prob t. 2 is inside parentheses, and also 100. 2 is the value that t is going to be less than or equal to. 100 is the degrees of freedom for the t distribution in question. SAS needs to know, of course, both of those pieces of information to look up the correct probability. And then what will happen is we'll get 3 values in the data set. We'll need to print those values out. So here's a proc print to print those values out. Let's go ahead and run this, and then I'll come back and say one more thing about it. That was fast. Here are the probabilities. I can make the font a little bit bigger so it's easier for you to see on the YouTube video. Let's go up to a 15 size font. There are the probabilities. The probability that a binomial random variable with 10 trials and probability of success 0.1 takes on a value less than or equal to 3 is 0.98720. The probability that the standard normal random variable takes on a value less than or equal to 2 is 0.97725. And the probability that a t random variable, which has 100 degrees of freedom, takes on a value less than or equal to 2 is 0.97589. Simple as that. You can throw your binomial, normal, and t-tables away if you'd like to do that, as long as you have SAS available to do the probability calculations. Now, one last thing, coming back to the program, notice that all of my probabilities of interest involved the random variable being less than or equal to some value. Yep, those are the specific types of probabilities that each of these functions calculate, less than or equal to. If you want to calculate probability x equal to a particular value for a binomial distribution, you might be interested in that, well, then you're going to have to manipulate this expression on the right-hand side of the equal sign. If you want the probability x, let's say z is between two values, you're going to have to manipulate the value on the right-hand side of this equal sign. Now, I've given you some hints in the lab notes about how to do this. Let me take a quick peek. I tell you that, well, if you want probability x greater than or equal to some value a, you are going to need to use the rule of complements. Think about that. If you have a binomial random variable and you want to calculate probability x exactly equals some particular integer value a, well, then you're going to actually have to calculate probability x less than or equal to a minus 1 and subtract that from probability x less than or equal to a if you're hoping to use the prob_BNML function. Think about why that's the correct subtraction, and then think about how you would implement that in SAS. If you have a binomial random variable and you want to calculate probability x is between a and b inclusive, you're actually going to have to subtract probability x less than or equal to a minus 1 from probability x less than or equal to b. Again, you need to think about that and work out why that's so, and then think about how you'd modify the program we just went through to calculate that probability. And I'll leave you to read the rest on your own. Your homework for Lab 6 having to do with these functions will ask you to find more complicated probabilities. Check with your lab instructor or friendly neighborhood teaching assistant or instructor for help if you run into problems.